Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on gradient. So gradient, we usually, for some reason, give it the letter M in linear relations. What actually is the gradient? It's actually the slope of the line. If you like, it's a measure of the steepness of the line. So if I say find the gradient of a line, you give me one number that indicates how steep the line is. Larger gradient means it's steeper, smaller gradient means it's flatter. So let's look at the lines in the Cartesian plane on your screen. So let's first look at A, the blue line, and B, the green line. So hopefully you can see that B is steeper than A. Think of it like a hill. It would be harder to walk up B than to walk up A. So the gradient of B, even though we don't yet know what it is, will be greater than the gradient of A because B is steeper and A is flatter. So another way to look at it is the larger the gradient is, the more vertical the line is. Now, note B and A both lean to the right. So what that means is as X is increasing, so as we go across here, X values are increasing, the Y values are also increasing. As we go across to the right, we go up. So that's the case for A, also for B. If we go right, we go up to stay on the line. If we go right, we go up to stay on the line. C, on the other hand, is different. So if we start at a point here, if we go to the right, we have to go down to stay on the line, right and down. So even before we've calculated the gradients, we need to know the gradient of B, so that's what M sub B means. Gradient of B and the gradient of A are both greater than 0 or positive. So positive gradient means the line leans to the right. As you go to the right, you go up to stay on the line. Whereas the gradient for C is actually negative, less than 0. And lines with a negative gradient lean to the left like that, because if you go across to the right, you have to go down to stay on the line. Cross and down, okay? So D and E are sort of special cases. It turns out the gradient of any horizontal line is 0, and the gradient of any vertical line is infinite or undefined. We will see why that is a bit later when we look at calculating the gradient. So how do we actually calculate the gradient? Well, the whole point of the gradient is we want to see how much does y change, how much do we go up or down every time x changes. We usually write this as rise, how far you go up, over run, how far you go across. So the rise is how far you go up. The run, the way I'm going to explain it, is how far you go to the right. So that will give you just one number, it may be a fraction, and that number indicates how steep the line is. So let's go ahead and calculate the gradient of the lines. Let's start with A, the blue line. So what you do is you pick any 2 points, say this one and this one. Start at the leftmost point and figure out how far do you go across and up. So to get from the first point to the second point, I've gone across 3 to the right and up 3. So the gradient of A is rise, how far I've gone up, over run. 3 divided by 3 is 1. What that means is each time I go across 3, I go up 3, or each time I go across 1, I go up 1 to remain on the line. Let's calculate the gradient of B, which is the green line. So what we need to do is we need to find 2 points that are very clear. So let's pick this point, and we'll pick this point here. So start at the leftmost point. How far do we go across and up to get to the second? So we go across 2 and up 5. Across 2, up 5. So the gradient of B is how far we've gone up over how far we've gone across. 5 over 2. So that means every 2 you go across, you go up 5. So 5 over 2 is 2.5, which is obviously more than 1. So the gradient of B is larger than the gradient of A because B is steeper. So let's look at the gradient of C. So once again, what we're going to need to do is we're going to need to pick 2 points on the line that are really clear to see. So I'm going to pick this point here and this point here. So to get from the leftmost point, we go across 2. So for the gradient of C, we've gone across 2, but we actually have gone down. You've gone across 2, but down 1. So when you go down, you put a negative. Remember, the gradient of C is negative because it leans to the left. So the gradient of C is negative 1 over 2. So it is flatter than the gradient of A or B. Now, the reason that the gradient of D is 0 is because if I look at rise over run, the rise is 0. It's not going up. If you pick any point on the line and go across, you don't go up. 0 divide anything is 0. That's why the gradient of D is 0. Now, the gradient of E is infinite because the run is 0. So I'm not going across at all. So you can't really tell me how much you go up every time you go across because you don't go across. So that's why the gradient of E is infinite. So now we're just going to quickly look at calculating the gradient where you're not given a picture. So what we're going to do now is calculate the gradient of the line that passes through these 2 points, -1, 3, and 4, 18. So there's only one line that will go through those 2 points. Now we could draw up our Cartesian plane and plot the points, but that takes too long. Especially, you know, the y value is 18. We don't want to have to mark our Cartesian plane all the way up to 18. So how do we calculate the gradient? Well, we know the gradient is the rise over the run. So the rise is how far you've gone up. It's just the difference in y values. So it's just the y coordinate of the second point minus y coordinate of the first point. That's how far you've gone up. And how far you've gone across is just the x coordinate of the second point minus the x coordinate of the first point. So we label our points x1, y1, x2, y2 like this, okay? Remember, the x coordinate is always listed first. Make sure you see that the two y values go together on top, okay? So it's not, 3 minus 1 on top. It's on top is y2 minus y1 over x2 minus, now x1 is -1, so it's 4 minus -1. And that makes sense. We've gone from 3 to 18 in y values. We've gone up 15. And then how far we've gone across from -1 to 4, we've gone up 5. And that's what the gradient is. 15 over 5, which is 3. So the gradient of this line is 3. That means each time the x value increases by 1, the y value increases by 3. If we were to graph the line, you'd have a point. Each time you go across 1, you go up 3. Across 1, up 3. So the line would look a bit like that, okay? So that's what the gradient is, a measure of the slope of the line. We can calculate it with or without a picture. All right, thank you so much for tuning in. This has been the luckiest maths teacher in the world. Have a great day.